Hey guys, welcome to the channel Views of Princeton. Today we are going to see about the presentation of design and fabrication of tri-arm coaxial hexacopter. Today our agenda is to start with the abstract, objective, introduction, literature survey, methodology, results and discussion, budget, and finally with the references. As we all know that there are too many technologies involved in today's agriculture. Drones in agriculture can be used for a variety of different tasks aimed to increase farm crop yields. This paved the way to design a drone mounted with spraying mechanism having 360 kilowatt high torque brushless motor using 30 ampere ESC, 2-blade glass fiber propellers, 32-bit flight controller with aluminum tubes, plates fixed drone for monitoring spraying process. This type of drone reduces time, number of labor, and cost of pesticide applications. Our project objective is the downwash. In aeronautics, downwash is the change in direction of air deflected by the aerodynamic action of an airfoil, wing, or helicopter. In one way to reduce drag is to change the wingtip by adding a winglet, reducing wingtip vertices. Our scope of this project is to using Hexacopter, it spraying mechanism will be executed and it will be useful and we can prevent the infections to the human. Our goal is to set a tri-arm coaxial hexacopter with the use of two-blade propeller with various pitch to experimentally test the field and downwash spray. As we all know that drones is otherwise called as unmanned aerial vehicle, that is UAVs. Drones officially known as UAVs regulated by the Federal Aviation Administration. A drone is an aircraft that flies crew on board. Drone is developing each and every day in this overall world. Drones are have some specific categories that is recreation models for hobbyists and civil and also it is useful for civil purposes that is commercial class drones and for public municipalities used everywhere for the sanitation works. So there are four types of drones that is single rotor, multi-rotor, fixed wing drones and fixed wing hybrid drones. There are several components are used in drones. For example, airframe, landing gears, wings, propellers, flight controller, GPS module, and battery, so on. Before starting with the project, we have done the literature survey. We looked a lot of papers, but these six are the major type content of our project. First, author Fabrizio Zargini, he analyzed an heavy lift drone using the numerical method of the spraying technique. He analyzed the flow field using the multi-rotor drone. And after that, we looked the experimental identification, research, design and development, implementation of propellers. Each and every author papers are useful for us to develop and fabricate our drone. These are the methodology. First, we started with the designing. Based on various factors and parameters, we estimated weight stabilization and thrust ratio for our drone using the CATIA software. And we moved with fabrication. Using aluminum tubes and plates, we initiated the build of the frame. And after that, we fabricated. After fabrication, we moved with the processing work. We calculated all those electronic items. We corrected the correctness of electronic items undergone. Stability were calculated, controllability, and all things are analyzed in real time. After that, we moved with the testing work, with the flight test using mission planner and spray test are also done. After that, we finally concluded with the launch of our project using our with the results are reported with calculations and graphs with the guidance and support of our project supervisor. The first and foremost is designing methodology. First, we designed with the base plate using CATIA V software with various parameters. It is very interesting and crucial. Designing is one of the important and the first major part of manufacturing process. And then we continued with the arm designing using the plane area 0.024 meter cube. It is one of the important thing where and when we have to work with the designing using various parameters. We have to analyze and we have to get the perfect parameters for designing the parts. After that, we used to assemble the both the base plate and arm in the SolidWorks software because SolidWorks software has some advantages of and it is easy to assemble in SolidWorks software. So, and after designing work, we moved with the fabrication. First, with the fabrication of base part. Using first, we selected material aluminum. Why we selected aluminum? Any guesses? Okay, cool. I tell you that aluminum has a high thermal conductivity, so that it helps to cool the mortar. And also aluminum is a fine material for multi-copters and also it is easy to fabricate. This base part fabricated by lathe machining process. And then we also fabricated and for arm also we selected material aluminum. The arm which is able to easily and quickly change its configuration. So these are the pictures how we worked in the fabrication methodology. In the first picture, you can see we measured the plate and then we drill the aluminum plates. You can see the third picture, video clip, lathe cutting of aluminum material using the guidance of the lathe industry. And after finally, that is a picture of the completed fabricated drone. And after fabrication, we moved with the assembly works. Yes, so these are the items, we materials we are ready to use for our project. So this first thing is iTalk brushless DC motor. Its RPM is around 360 kilowatts and weight is around 112 gram. And then RC transmitter. It's so costly, guys. RC transmitters and high torque brushless DC motor and ESCs are so costly. We need to be very cautious whenever we used or working with this material. ESCs suitable batteries for all these things is 4S batteries. It is lipo battery. I suggest you the better company for this 4S battery is Bonka. It's one of the best company brand for lipo batteries. These are the pictures how we assemble. The first picture you can see that fixing the propeller and then mounting the motor. And after that, you can see that soldering. Soldering is very important part of assembly. And we finally added arm to the frame using nuts and bolts. So this is the Triarm Coaxial Hexacopter specification. So why we selected Y6 configuration? Any guesses? Okay, I tell you that. So Y6 is basically a less weight frame, and then its large field of view is the major advantage, and it's also good for aerial photography, and it also less efficient. While yawing, it loses altitude. This is the complete fabricated and assembled coaxial hexacopter. Actually, in the aluminum material, we use spray painting, black color. We sprayed everything as a black. If we finished work with the all the using all these wires were inserted in the some kind of cover. So first thing you can see the top of view of the hexacopter, and here is the front. At the right side, you can see the front of the hexacopter. Yes, mission planner. It's one of the important software. It is used to control the vehicle, set up missions. We can alter the parameters of the drones. So yes, mission planner is one of the best control station for copters and also for rovers. This is where you can set the 6 flight modes controlled by the flight channel. You can see at the flight data, it is easy way for beginners to generally adjust roll and pitching, all those things. This screen provides access to parameters. We can adjust all those configurations, extended and basic tuning can be done here in this mission planner. We can also set the flight modes, automatic, launcher, or drift. So yes, finally we here to discuss about the results of our project. Yes, first we did the testing of motor at ground level. You can see the graph, power versus efficiency, speed versus efficiency. Total down we got to 9 kg. Motor at optimum efficiency, we got around current 7.98 ampere. Voltage also 13.82. The efficiency we got around 85.0 percentage, that is around 85. At maximum speed, its revolution is around 4106 rpm. Efficiency 78.1 percentage. It took voltage around 14.25 volts. Our battery is totally got dry when we tested at maximum speed. Spray test, yes, we used misting nozzle for spray test. Misting nozzle is very effective, and it has green outlet and it is not blocked. It has high quality recyclable plastic material. So there are two types of basic types of nozzle, misting nozzles, that is brass type and ceramic types. So you can see at the bottom that these are the values we derived from the spray test at ground level. Around footprint width around 0.8 into 0.7, continuous volume 1 and 2 is 33 and 15. Spray test video, you can see how it's spraying the second video. Wow. We sprayed on the flat ground. You can see at the third picture, we sprayed how it sprayed on the flat ground. It it is very interesting. You can see in the first video, it's spraying with running motor. Motor is running. You can see how it's spraying in the flat ground. At the yes, this is the anti-clockwise motor. Wow, so cool, no? Yeah, yes. So these are the spray tests we took as a result. So it is really interesting. And yeah, this is the overall budget of our project. We spent around 50 to 60K for design and fabrication of Triarm coaxial hexacopter. Guys, you can see that autopilot flight controller is around 5,000. So it's very costly, guys. We need to be very cautious when using these. You can also see electronic speed controllers. You can see brushless DC motor is so costly. It's around 14,000. So guys, you need to be very cautious each and every minute whenever you're using all these items. Conclusions, yeah, we finally we came here for the conclusions. Voice 6, yes. We got electronic problems from ESCs connected with our motor. Frequently, we got most of error in our ESC. We tried to rectify it in numerous ways, but we can't finish it. So we delayed in drone takeoff and we can't finish the experiment in our time. So that under the guidance of a supervisor, we took the experiment at the ground level, done the motor test to calculate thrust and spread in the cement ground. Sure, at this moment in future we need to be really enthusiastic to do, upgrade our project or rectify the ESC problems, and after that surely we will be continuing our work. All those flight drone takeoff will be done, and the spraying mechanism also will be continued at the agriculture farmland. Yes, so future work, as we know that in future drones are going to work or going to big a revolution in the world. It also going to provide new opportunities in transport, military, logistics, and commercial sectors. As these technologies continuing, it's evolving each and every day, and it grows. Drones will become safer and more dependable. It can be used for medicine, buildings, unmanned cargo transport, border control surveillance. Everywhere, each and every sector, drones are going to rule the technology in future. So these are all the references we took for our project. So yes, there are many references. All these references help us to do our project. Although our project is a failure, it's something we gained, some knowledge we gained through this project work. Thank you everyone for listening and watching this presentation. So soon I'm interested to come with the another interesting topic or video to this channel. So thank you guys. Thank you for listening and looking at this presentation. In some way, it is going to help you, or you can also work with this project and make it as a successful project with this Y6 Hexacopter. Thank you guys. So don't forget to subscribe Views of Princeman. Thank you.